So the objective of the lesson is I can identify a parent function given any function. So a parent function is known as the simplest function of a family of functions. So these can include quadratics, quotient functions, cubic functions, and radical functions. And remember, each of these can be rewritten. And really, now that we're in function notation, I should rewrite these with different letters. So how about we do f of x, g of x, h of x, j of x. That's proper function notation. So here we have a linear function, f of x equals x. So we're going to go ahead and choose values of x. And what I always like to do is just choose any values. So I'm just going to do -2, -1, 0, and 1. So then we can go ahead and fill in our values. So what happens here is each of the values here replaces the x when we evaluate the function. So we do f of -2 is -2, f of -1 is -1. The same will go for f of 0 and then f of 1, so we can go ahead and fill in our table. Now that we have our table filled out, we can go ahead and graph our function. So we go to -2, -2. And we do the same for the other values. Okay, so then for our domain, we're going to do everything in interval notation. So it's from -infinity to infinity. The same will be for the range. Then where the function's increasing. So a function is increasing if, so it increases if as the inputs increase, the outputs increase, and then it's decreasing if, and then a function's decreasing if as the inputs increase, the outputs decrease. So here the function's increasing the whole time, so we write from -infinity to +infinity, and it's never decreasing, so we write non-applicable. And then for our x and y intercept, it's the same value, it's 0, 0. I just want to point out that we can also plug this into Desmos by going to desmos.com, and you can see the whole graph, and you can actually zoom out and look at it from afar and determine key characteristics. All right, here we're working with absolute value functions, so we can go ahead and choose our values for x. Again, I just chose -2, -1, 0, 1. So we're going to go ahead and plug these values into our absolute value function. So here we plugged in our values of x, and then here are our outputs. So we're going to go ahead and graph these points. Now that we have them, we can go ahead and draw our graph. So you might wonder, how do I know that I'm drawing the correct graph? The answer is I actually really don't. But what I'm going to do is first check this using Desmos, and then I will show you. Now, I know that this is the graph because I've done this a million times, but I'm saying like to check your answer and just say, okay, am I sure that these are going to really show the behavior of the graph? Just graph it in Desmos and double check. So we type f of x equals, and then I need the absolute value sign of x. You can see that it is pretty much the same. This will go on forever. And as you zoom out, it gets steeper and steeper, and as you zoom in, it gets more and more narrow, and that's just because of the window you're using. Now some information about the graph. The domain is from -infinity to +infinity. The range is only from 0, including our value of 0 to infinity. The x and y intercept are actually the same at 0, 0. And then for this graph, it's increasing from 0 to infinity, and it's decreasing from -infinity to 0. Okay, so now we have our quadratic function. So the function is f of x equals x squared. So if we had something like -1, -1 squared is going to be 1. 0, 0 squared is 0. 1, 1 squared is 1. 2, 2 squared is 4. All right, that's enough to go ahead and graph. So the domain of this graph is all real numbers. So in interval notation, that's negative infinity to positive infinity. And then the range is y must be greater than or equal to 0. Interval notation, 0 to infinity with a bracket. The x and y intercept is here. This is 0, 0. So the x-intercept is 0, 0, and the y-intercept is 0, 0. Then this graph is increasing on 0 to infinity, and it's decreasing on negative infinity to 0. Okay, next we have a cubic function. So the way this works is if we took 0, 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. 3 to the third power is 27. So this graph actually increases very quickly and decreases very quickly. So we're going to go ahead and draw it. So this is our graph. The domain is all real numbers. So in interval notation, that would be negative infinity to positive infinity. And then the range is also all real numbers. In interval notation, that would be negative infinity to positive infinity. Your x and y intercept is here. That's 0, 0. And then your graph is increasing on negative infinity to positive infinity, and it's decreasing never. Here we have a root or radical function. So really quick, we just want to talk about that. This function, if we were to do f of negative 1, we would have the square root of negative 1, which we do not really consider a real number. This would be an imaginary number. So with that said, our inputs cannot be negative. So our domain, I'm just going to state it right now, is from 0 to infinity. So let's go ahead and evaluate some of these inputs. So I chose perfect squares. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So I can go ahead and graph those. So I plotted the points, and now I draw my line. And then I have an arrow to show it goes on forever. So our range is going to be also the same. It's going to be from 0 to infinity. We are going to have an x and y-intercept that are the same, 0, 0. And then the graph is increasing, so it's increasing from 0 to infinity, but it's never decreasing. So we can go ahead now and check on Desmos to make sure we did this right. So you can see here that this graph, again, is accurate. It only exists in the top right quadrant, the same as ours. Okay, here we're now going to look at the graph of a reciprocal function. So really quick, let's choose our values of x. I kind of added an extra value too because you'll see in a moment. So I'm actually going to start with 0. So f of 0 is undefined. And in fact, what's happening at 0 is we have a vertical asymptote at x equals 0. So we basically have this invisible line the graph will never cross. So we can go ahead though and plot our remaining points. So at -2, we are at 1 over -2 or -1/2. -1, we're at -1, 1, we're at 1, and 2, we're at 1/2. So let's go ahead and plot the points. And if we were to keep graphing these values, it would get closer and closer to the x-axis, but it would never actually cross it. So that is how one side of the graph will look, and this is how the other side of the graph will look. It never touches the x-axis though. So the domain is going to be -infinity to 0, not including 0, union 0 to infinity. And the range is also going to be -infinity to 0, union 0 to infinity. And don't really worry too much about y right now. We'll talk about that more later in the course. So here there's no x-intercepts or y-intercepts. And so this graph, as far as increasing, it's actually never, it's never increasing but it's always decreasing. And you can tell as these x values get larger, the y values continue to get smaller. As these x values get larger, the y values continue to get smaller. Okay, so after that, you should be able to identify parent functions from equations.